Welcome back. So we are learning about the mesh analysis. So let's have a look at the next example, which is basically about the circuits with the independent current sources. So we have this circuit. So we want to get V naught using the loop analysis or mesh analysis. So V naught is the voltage drop between these two nodes, right? So using loop analysis, first of all, we need to find the loop currents. So we need to define the loop currents. So we have defined the currents here. So like in this loop, the current is I1 with this direction. In this loop, the current is I2 with this direction. In this loop, current is I3 with this direction. So if these loop currents are not defined, you can define it yourself. Okay. So our target is to get V naught. So V naught again is a voltage drop between this branch. So that will be basically voltage drop here, like across 6K. What will be the 6K? And the current will be I3, and minus 3. So this is the basically equation of our output. Now to get that, basically we just need to find the value of I3. Now how we can find that? We need to use the loop analysis. So after defining the loop currents, the second step is to write the loop equations, mesh equations. Now here the difference between this example and the earlier example is that here we have basically current sources, independent current sources. So once we have independent current sources in a loop, which is basically not shared between the two loops, what we can do, we can directly write that loop current based on that. For example, if we consider this one, so through this loop, the current that will be flowing, it will be basically the same current, like this current will be flowing through here. So I can say that I1 is basically 4 milliampere. So I don't need to write a loop equation here, I can directly get the value of I1. So the purpose of writing loop equation is to get the current values. And as we can get it directly here, so we don't need to rewrite it. Similarly, if you look at this one, second loop, so again we can see that the current through this one will be basically same current that is basically flowing this one. So actually we have defined the direction like this one. So again directly we can write the value of I2 will be minus 2 milliampere. So we have the two loops and we got those two loop currents. So it means we don't need to write the loop or mesh equations for these two loops. So we are left with only third one. So here we can define the polarities. And then based on that, let's write the equation. So let's start from here, across 4 kilo. So voltage drop here will be plus 4. So what are the currents flowing through this one? The one current is I3, this one. And the other one is I2. So what will be that? I3 minus I2. Again K I am not putting because we will divide it at the end and that will be milliampere, because all resistors are in K. Then the voltage drop here plus 2 times of, again what will be the current here? It will be again I3 and what is the other one? I1. So this is the direction of I3, this is the direction of I1. So we can write it here as I3 minus I1. So always difference of loop currents, but the reference will be higher current will be the reference loop current, for example I3 for this case. Then we have this resistive branch here. So voltage drop here will be 6 times of current. What is the current flowing through this one? Only I3. So 6 times of I3, and lastly this voltage source minus 3 is equal to 0. So basically we have only one loop equation here. So let's simplify this. So 4 times of I3, it will be 4 times of I3, and minus 4 times of I2. What is the value of I2? Minus 2 milliampere, right? So minus 4 times of I2 is minus 2, Then 2 times of I3 minus 2 times of I1. What is the value of I1? 4. So I can plug in that value here. Plus 6 times of I3 minus 3 is equal to 0. So basically we have one equation, one unknown. We can just simply rearrange the terms here and we can get the value of I3. So let's do that. So we have 4I3, 2I3, 6 and 6I3. So we have basically 12I3. What are the constants? So minus 4 times minus 2, that will be plus 8. Then we have minus 2 times 4, that will be minus 8, and we have minus 3 is equal to 0, right? So what do we have here now? Okay, now here minus 8 and this 8 will be cancelled. So I can say that basically the value of I3 will be 3 over 12, which is basically 1 over 4, and the unit will be milliampere. So we got our all loop currents. Okay, I3, I1 we already have. Our target is to get V0. So what will be V0? 6K times I3. What is I3? 1 over 4 milli minus 3. So what we will have here? So milli and K will be cancelled. So basically we have 6 over 4. So that will be 2 times 2, 2 times 3. So 3 over 2, that is 1.5 minus 3, right? So 1.5 minus 3, that will be basically nothing, just minus 1.5 volt, okay, or minus 3 over 2 volt, okay. So this way we can get basically our desired output. So the purpose of loop analysis is to get the loop currents, and once we have that, then whatever we need to find, we can find it directly. Thank you so much.